Hello students, today let us take a previous year question from the errors topic. A physical quantity x is given by this equation, x is equal to 2k cube L square by m root n. The percentage errors in k, L, m, n are 1, 2, 3 and 4. What is the percentage of error in x? Here is an equation where x is equal to some formula, 2k cube L square into m root n. Now they are saying each measurement of k, L, m, n has these errors, and what is the error in the final value of x. When you are adding quantities or subtracting quantities, the absolute errors get added, are added. In multiplication or division, relative errors or percentage errors, either relative or percentage, they get added. We have to be very clear here, student. Addition or subtraction, in both cases the absolute errors get added. Multiplication or division, the errors in each of these quantities, the relative errors or the percentage errors get added. What about power? Let us say a cube. What happens to the, let us say this quantity is z. So a cube is z. What happens to the relative error? This power is multiplication in another form, right? So the error gets added 3 times, or the power into the error of A is the error in Z. And even division, always the errors absolute or relative get added. These are the underlying principles. Now using this, pause the video and try to solve it on your own. So this is what we have. What happens? In powers, the error gets multiplied by the power. So now we have k cube. Whatever is the error in k, it gets multiplied by 3 for k cube. So the error in k is 1 and q. So in k cube, the error is 3%. In L square, whatever is the error in L, it gets multiplied by 2. The error in L is 2%, it gets multiplied by 2. We have 4%. And we have m. M is 3%. And we have n root of n, or n power half. So the error in n power half is half into 4, that is 2%. So in k cube, the error is 3%. In L square, it is 4%. In m, it is 3%, and root n is 2%. So these get added up. So 3 plus 4, 7. 7 plus 3, 10. 10 plus 2, 12. So the final percentage of error in x is 12%. So this is the answer. This was asked in Telangana 2023 EAMCET exam, and a similar ones get asked in NEET or JEE Mains too. Hello students, let us look at this previous year question from the errors topic. Consider a series of measurements of the length of a box in an experiment. The readings are 2.4, 2.5, 2.6, 2.8 and 3.0 meters. What would be the relative error? If you don't know what relative error is, please look for the video in the description which talks about errors, and then please come back to this PY. How do we find the relative error? What we do is we find out the absolute error in each measurement. Now what is absolute error? The difference from each reading with the actual reading. The actual reading is not given here, so the actual measurement would be the average of all these measurements. So we average this, and then the average, what is the difference between each measurement and the average? That would be the absolute error in each reading. We take all the absolute errors and then find out the average of that. That would be the mean absolute error or the average absolute error. The average absolute error divided by the average of all these. That's the true value. That would give the relative. Okay, so what's the average of all this? If we sum up these measurements, we have 13.3, and if we take the average, 2.6. So this 2.66 meters is considered as the true value of the measurement of the box. So now what we do is we find out the absolute error. Absolute error is how much each measurement is away from 2.66. We take the absolute value, we ignore the sign, and what do we get? So these are the absolute errors in each of the measurement, and then we take the average of that. So the total is 0.96, and 0.96 divided by 5, 0.192. Now, this is the mean absolute error, the average of all the absolute errors. And our relative error is mean absolute error by the actual value, 2.66, 0.072. So, this is our final answer. Hello students, let us look at this PYQ. The error in the length and breadth of a table is 1%. If length is equal to 1 meter and breadth is equal to 50 centimeters, the area of the table is 0.5. These are the options: 0.5 plus or minus 0.1 meter square, 0.5 plus or minus 0.01 meter square, so on. This was asked in Telangana EAMCET 2021. Pause the video and try it on your own. So let us see this. Length is 1 meter and breadth is 50 centimeters. So let us get them into the same units. Length is 1 meter and breadth is equal to 50 centimeters or 0.5 meter. And what is the area? Area is length into breadth, that is 0.5 meter square. Now the error in length is 1% and breadth is 1%. Area is equal to L into B. The percentage of error in L is 1 and B is 1. What happens to the errors when there is a product? The errors get added up. Here 1% and the 1% in this get added up, and the error in area will be 2%. So what is 2% of 0.5? So 0.5 into 2 by 100. So that is how much? 1.0 by 100 or 0.01. So this is the error in area. So our final area with the error would be 0.5 plus or minus 0.01 meter square, or 0.5 plus or minus 0. This is our final answer. Hello students, let us look at this PYQ. The errors in the measurement which arise due to unpredictable fluctuations in temperature and voltage supply are. This was asked in NEET 2023. Random unpredictable fluctuations in temperature and voltage. This is random errors. This is the right answer. It's a fairly simple question. But let us go through all these. Personal error. Personal error is the person who is taking the measurement made a mistake. That is personal error. Least count error. Least count error is when you cannot measure lesser than what the instrument can measure. If the instrument can measure only up to 1 millimeter, you cannot go less than that. That is the least count error. Instrumental error. This is occurs because the instrument is faulty or there is some mistake with the instrument. So these are all the different errors. Hello students. Here is a question from NEET 2024. In an electrical circuit, the voltage measured is V is equal to 200 plus or minus 4 volts, and the current measured is I is equal to 20 plus or minus 0.2 amperes, and the value of resistance is, these are the given options, and they want us to find out what is the value of resistance. Please pause the video and try it on your own. So the formula for resistance is R is equal to voltage by current. This is the formula. Now they have given voltage is 200 plus or minus 4. So voltage is equal to 200 plus or minus 4 volts, and current is equal to 20 plus or minus 0.2. So, and they are asking what is the value of resistance. Now these are absolute errors, but to calculate the error in a multiplication or division, we cannot work with absolute errors. We need relative errors or we need percentage errors. But this is absolute error. From absolute error, we have to go to percentage error. How do we do that? We do that by taking the error divided by the actual value. So this into 100. This is the percentage of error in voltage. So we have 2. So the percentage of error in measurement in voltage is 2%. Similarly, current. What is the percentage of error in the measurement of current? It is 0.2 divided by 20 into 100. So we have 2% error in voltage and 1% error in current. Now what happens to percentage errors in division? They get added. So the final resistance will have an error of 3%. So the value of R. R is equal to V by I, that is equal to 200 voltage by current is 20. So we have 10 ohms. R is equal to 10 ohms, but the error is so 2% plus 1. So we have 3% error in the measurement of resistance. What is 3% of 10? So R is equal to 10 plus or minus 0.3 ohms. This is our final value, which is this one here. So this is our right answer. Hello students, let us look at this PYQ. Two resistance are given as R1 is equal to 10 plus 0.5 ohms and R2 is equal to 15 plus or minus 0.5 ohms, and the percentage error in the equivalent resistance when connected in parallel is. This was asked in JEE Main 2023. Yeah, please go ahead and pause this video and try to solve it on your own. What is the equivalent resistance? We know that when two resistors are connected in parallel, the equivalent resistance is R1 into R2 by R1 plus R2. So what they are asking is, if this are the variations in R1 and R2, what is the percentage variation in R equivalent? Let us say there is a quantity Z which is equal to A into B by C plus D. If this is the quantity Z, then the relative error in Z or the percentage error in Z can be calculated by add the percentage of error in A, percentage of error in B and the percentage of error in C plus D. If we can add all of these, that would be the percentage of error in Z. But the rule is that is we can add those only if all of these A, B and C plus D are independent of each other. They are all independent. They are all different. But here if you look at this, we can't do the same thing with here because R1, R2 are both in the numerator and in the denominator. So the numerator and denominator are not separate. So we cannot just add them. We have to use calculus to solve this equation. So what is the R equivalent? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. This is the formula for parallel resistance. So if we differentiate, what do we get? We get minus d R equivalent by R equivalent square is equal to minus dR1 by R1 square minus dR2 by R2 square. And since minus is everywhere, we can take it common and we get dR equivalent by R equivalent square is equal to dR1 by R1 square plus dR2 by R2 square. So what calculus has beautifully done is, for a small variation in R1 by R1 square plus for a small variation in R2 by R2 square gives a small variation in dr cube by this one. So now if you look at this equation, what is the variation in R1? So we have variation 0.5. What is the variation in R2? We have 0.5. R1 is 10 and R2 is 15. And if we find out R equivalent, what do we get? R equivalent is equal to, using this formula, we have R equivalent is equal to 10 into 15 by 10 plus 15. So that is equal to 10 into 15 by 25, 5 5s, 5 3s, 5 2s. So we have 6 ohms. So let us dR equivalent by R equivalent is 6 ohms. So we have 6 into 6, 36 is equal to dR1 0.5 by 100 R1 square and R2 square is 225 plus 0.5 by 225. So what do we get? So dR equivalent is equal to 36 into, let us take 0.5 out and we'll have 225 plus 100 by 100 into 225. Alright, let us write it here. So we have 36 into 0.5 into 325 by 225 into 100. 26 by 100, 26, that is equal to 0.5. 0.26. So all this calculation has given us DREQ. So DR equivalent is equal to 0.26. But he wants percentage. So percentage is DR equivalent by R equivalent into 100. So 0.26 by 6 into 100. That gives us 4.33 percentage. So this is our right answer. Hello students, let us look at this PYQ. A cylindrical wire of mass has length and radius. The maximum error in the density will be how much? This was asked in JEE Main 2023. Please pause the video and try it on your own. So what is the formula for density? Density is mass by volume. So what is the volume here? It's a cylindrical wire. He has given radius and length. So the volume of a cylinder is what? Pi r square L. So this is the density. So now because mass, radius and length are all independent variables, we can calculate the relative error, the percentage error in all of these, and we add them up to get the percentage error in density. Okay, so what is the percentage of error in mass? Percentage error in mass is equal to 0.01 by 0.4 into 100. So what do we get? 4 or 2.5%. Let's calculate the percentage of error in radius. Radius is percentage error in radius is 0.03 by 6 into 100. That is 3 by 6 or 0.5%. This is the error in radius. What is the error in length? Percentage error in length. Length is 0.04 by 8. 0.04 by 8 into 100 or 4 by 8, and we have 0.5. So these are the individual errors. But here we have r square. This total error becomes 2 into r. So we have 1% in r square. Mass is 2.5% and length is 0.5. So if we add all of these, what do we get? We get 4. So 4% is the error in calculation of density. So this is the answer.